We tend to think of maps as pretty simple tools, right? They get us from point A to point B, but what if there's so much more than that? What if they're actually snapshots of human understanding, capturing knowledge way beyond what their creators ever imagined? All right, let's get into it.
I want you to imagine a map, not just as a picture of a place, but as a kind of time capsule. It's preserving observations and patterns that, at the time, nobody could explain, and maybe wouldn't be fully understood for centuries.
And that right there is the big idea. For hundreds of years, some of the most profound scientific truths were just hiding in plain sight. They were encoded in the lines, the colors, and the shapes on maps, long before we had the science to actually figure out what they meant.
So where do we start? Let's start with the secrets that were hidden in the solid Earth itself. These are massive discoveries about our planet's deep past that were charted completely by accident. Let's hop in a time machine and go way back to the 16th century. A mapmaker named Abraham Ortelius is putting together the world's first modern atlas, and he notices something kind of weird. He's looking at the coasts of South America and Africa, and he sees that they look like they could just slot together, like puzzle pieces. He even threw out a wild idea that maybe they were torn apart by earthquakes and floods. Now here's the absolutely wild part, the time gap. Ortelius saw this in 1570. But it took until 1912 for Alfred Wegener to officially propose the theory of continental drift. For more than 300 years, the clue was right there on the map, a huge, flashing sign pointing to plate tectonics, just waiting for someone to connect the dots.
And this theme of accidental discovery just keeps going. Fast forward to 1815. We've got another map, but this time it's not a fancy world atlas. It's a super practical map of Britain, made by a guy named William Smith, for one reason and one reason only: to help miners find coal. So Smith is painstakingly charting out all the different layers of rock, the strata. And as he's doing this, he notices a pattern. Certain layers always had specific kinds of fossils, and they always showed up in the same order. Without having any idea what he was doing, he had mapped the history of life. The deeper, older rocks had simpler life forms. The shallower, younger rocks had more complex ones. This map, made for industry, was literally the first ever sketch of biological evolution, decades before Darwin even published his theory.
Okay, so maps helped us see the solid Earth, but they also, incredibly, helped us see forces that are completely invisible. Let's look at how maps revealed the hidden worlds of disease and the complex physics of the ocean. So, picture London in the mid-1800s. The top scientific theory for how diseases like cholera spread was called the miasma theory. Basically, everyone thought it was caused by bad air or foul smells. I mean, it kind of makes sense, right? If something smells terrible, you stay away, but it was completely wrong.
So during this absolutely brutal cholera outbreak in London in 1854, a doctor named John Snow comes along, and he has a hunch. He thinks everyone's wrong about the bad air. He thinks it's the water. And to prove it, he didn't reach for a microscope. He reached for a map.
His map made the truth impossible to ignore. He put a dot on the map for every single person who had died of cholera, and this terrifying but crystal clear pattern emerged. The deaths were all clustered around one specific public water pump on Broad Street. It wasn't some invisible bad air floating around. It was the water. That simple geographic pattern sparked a revolution in public health. Now let's jump to a totally different kind of invisible force. On the other side of the world, ocean currents. For centuries, Polynesian sailors navigated the vast Pacific using these incredible things called stick charts. They're woven from palm strips and shells, and they don't map land. They map the ocean itself, the way the waves move and interact. For the longest time, Western scholars kind of just blew these off, calling them primitive art. But recently, oceanographers decided to take a closer look, and when they compared the patterns in the charts to modern satellite data, wow, the revelation was just stunning. These stick charts are unbelievably sophisticated and accurate models of wave physics, showing exactly how waves bend and bounce around islands. It's a scientific textbook woven from sticks. So, we've covered geology, biology, germs, ocean currents, but the secrets that maps hold can get even bigger. I mean, we're talking about scaling up from our planet's climate to the very origin of the entire universe. Okay, get this. In the 1940s, radio astronomers were mapping the sky, but they kept picking up this annoying background static, a hiss that was interfering with everything. They thought it was just an error, maybe a problem with their equipment, but the noise was everywhere, coming from every direction. It wasn't until 1965 that they figured it out. What they'd mapped wasn't noise, it was the cosmic microwave background, the leftover glow from the Big Bang. A map of static turned out to be a baby picture of the universe.
And it's not just the high-tech scientific maps that hide secrets. You can find them even in these deeply symbolic, almost religious maps from the Middle Ages. They were accidentally recording climate data.
Take a look at the famous Hereford Mappa Mundi from around 1300. I mean, this thing is full of Bible stories and mythical beasts, but if you look closer, its drawing of the Nile River, while it looks weird, actually shows the pattern of its seasonal floods, which are driven by monsoons, something that wasn't understood for centuries. And the way it draws the symbolic cold north matches up with real accounts from Norse sailors about ice conditions at the time. It's a climate record disguised as art.
So, this isn't just a cool history lesson. This exact same process is happening right now. Our modern maps, the ones we use every day, are packed with secrets we're only just starting to figure out.
Think about those incredible satellite maps of the Earth at night, all lit up. They were originally made for stuff like city planning or maybe military intelligence. But then, scientists from totally different fields started looking at them, and they saw something completely different.
They realized these light maps were a perfect proxy for something else: the human impact on the planet. Ecologists could suddenly see, clear as day, how artificial light was disrupting animal migration. Climate scientists could track energy consumption and even estimate greenhouse gas emissions just by the intensity of the light. A simple map of our lights became this incredibly powerful, unintended tool for checking the planet's pulse.
So, what's the big takeaway here? It's that maps are never just maps. They're these amazing archives of unintended scientific knowledge. They capture real-world patterns, sometimes centuries before we have the tools or the theories to understand them. And it's a powerful reminder that science doesn't just move forward by discovering new things, but by looking at old things with new eyes. Which really leaves us with one last big question to think about. From the maps on our phones that track traffic to the satellite images that track storms, what profound secrets are hiding in those maps right now, just waiting for the right person to notice the pattern? Thanks for joining me.